All right, this is part 2 of my video report. This time I'm going to talk about messages and how they work, how I made them work. So let me pull up my notes. Right, so generally how I have structured things is that message is a class and it has two components. I use that term loosely, but it has a message header and message data. So the header has all these different information. So it has the message type, destination, execute time, delivery method, and channel. So every single message will have a message header that has all of these elements. But then different messages will have different message data, which I think like your phrasing for it would be a payload. So basically message data is the base class. And it has all these virtual methods, serializing, deserializing, executing, printing, and recycling. And then each one of the actual different message types, like message data types, implement these things. So these are where I have visual in different types. I have collision events, fire input, ship move update. So those are actually all my different types. So a message is you stitch together a header, and then where you specify, type is one of the parameters, or type is one of the fields, and here are all the different message types. So you have to stitch together a header with the right type, and then a data, message data part, which is one of these derived types, if that makes sense. So when you are sending these across the network, I'm on the server right now. So if I'm sending a message to the client, I serialize the message. And if you go to serialize message, you serialize the header, and then you serialize the data. So serializing the header just writes all that information into the buffer, and then serializing the data will depend on the data that you have. So it's a virtual method, and then each message data type implements it. So, and then deserializing, I said earlier, you basically deserialize that message header first, then do a switch based on the type to know what type the message data is, and then deserialize that. Then you have to build the whole message. So yeah, basically when you build messages, it's like kind of gross. It requires a lot of, it requires a huge block of things, but it makes a lot of sense in my head. So it definitely could be clearer, but it's just how I thought about it. So for instance, this is the server and this is player 2. And the player 2 sends a input message every frame. So what you have to do first is get a message header from the pool. You have to specify the type and the destination and whatever other things you want to specify. So if you wanted to put this on a particular channel, then you would specify that here, but everything defaults to reliably ordered on channel 0. For dead reckoning, literally everything goes on there because as far as I understand, we can afford that, and there's not that many messages being sent, and they all need to come, so we can use that. In the message header constructor, everything defaults to reliably ordered channel 0. That is also true in the header pool. When you get a message header, you default it to reliably ordered channel 0. So anyway, first you have to get the header, then you have to get the data that you want. So this is a move input thing for player 2. You're getting the horizontal and vertical axes. So you're filling in all the information, and then you have to build the whole message. So you get a message from the message pool. You basically say, hey, this is the header, this is the data, and then I'm going to add that whole message to the queue. So every time you create a message, you have to do all of this nonsense, which did start to get old, but I kind of like how explicit it is, but that's just me. So that is generally messages as an overview. I'll try to speed through going through each of these individually. So once again, these are the different message data types. They all inherit from message data. So collision event is what you'd expect. It has the IDs of the 2 different objects. You just serialize and deserialize those. When you execute them, you have to find both objects and then do the accept. This is called in the contact manager. So when you begin contact, this is where you build the message. you make it a collision event, blah, 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 send it across. So the server is the only one who's ever creating and sending these because he's the only one with physics enabled. Yeah. And these, no matter what, will always need to be reliably ordered. Whenever anything's reliably ordered, I just put it on channel 0. Which I know each different type has 32 channels, but yeah. So, sorry, that's collision event. Fire input, it just has the player, because it's just like a key press, right? So for whichever player it is, that's all you need to do. When you execute it, you build a spawn message and you pass on whatever player it is to that spawn message. So these are also very important, so they need to be reliably ordered. They are on the client, sorry, on the server, because my server is pretending to be player 2. These are sent when you do the input fire 2, and the exact same thing is on the client. When you press that down, you do the fire input message. Gonna go back to the server. This file, ignore it. I need to delete it. LayMine is another one. It acts the exact same way. When you execute it, you do a mine spawn message. It's also just when you press the right button. Move input message is the same when you press the input keys. I actually think I'm sending it every frame, not just when you press the input keys. But you take the player, the horizontal and vertical inputs, and then when you execute, you do a switch on the player to move or rotate the player, because this will only, all of the input messages will only ever get executed on the server. The clients send their inputs to the server acts stuff out, and then sends clients more information later. So yeah, this will act on the actual ships that are controlling the game state. So the all missiles move update message is basically a new message that I made when I realized for client-side prediction I needed to send all of the missile information at once. So this is basically it contains a list of straight up missile move update messages. So a missile move update message is for one missile specifically, but then all missiles will send all the missiles that are alive on screen. It will send all their information in one big message. So it has the list here. It basically, you serialize, you loop through however many you have and serialize them. Deserialize is the same. You read how many you have, and then you deserialize all of them. And then you just execute all of them when it executes. So I'll explain this more about client side because it's not used for Dead Reckoning. So missile move update has all of this information required for Dead Reckoning for a missile. Serialize, deserialize. When you execute, you get the right missile. Sometimes the missiles can be null because they could be sent after a collision because they're on separate channels. So if it is null, then you just ignore the entire message. If it's not null, then for Dead Reckoning, you update the prediction component of the server with the right data, and you also hard set the missile position, angle, and pixel velocity This will be executed on the client for Dead Reckoning. But yeah, so you update this stuff, and then you update the actual position, angle, and velocity on the client. Ship move update position is similar. It has all the information you need and does the same thing. You update the prediction component with the right stuff, and you hard set everything. Mine spawn is triggered like when you press the LayMine key. It builds a mine spawn messages and adds it to the queue. So here is mine spawn, and it just calls LayMine. This is executed on the server or the client. Missile spawn is similar. Nothing too crazy. Time reply and time request. So basically, I'm gonna go over here. Because we're doing Dead Reckoning, we do need time sync. So in the network manager, when you get a connected status, I request a time sync. So you basically add this time request message to the queue. The time request message holds, sorry, not the right thing. The time request message holds the time that you send it, right? So that's on the client. And then on the server, when it receives a time request message, it's like, okay, in response, I'm gonna build a time reply message. So the time reply message contains the time from the server's clock and the client's time. So it does Christian's algorithm like we talked about. Sorry. On the server side, when you receive this, you write all of this information into the time reply message, and then you send it back to the client. When the client executes the time reply message, you do the Christian algorithm thing and update your time with the right time based on the math. So, yeah, that only happens, I only do that once, maybe in a real game like we talked about, you would do a heartbeat or something and you would request a time sync more often, but I only do it once right at the beginning when I connect right here. I think that's all my different message types. I talked a little bit about delivery modes and channels. In terms of the recycling and pooling, I have a message pools class at the scene level. So this scene has a messaging pools class. The messaging pools class has a ton of different pools for all my different message types, and then a generic message pool and a message header pool. So whenever you are deserializing stuff or creating new things, you call message pool get message, or message pool get header, or whatever it may be. And basically there's a ton of these different classes, and each one of these has a stack of the specific type of thing, and it works just like any pool. It keeps a stack, and if the count is 0, you have to build a new one, else you pop the old one, or else you pop something from the stack. Yeah, pretty self-explanatory. When you recycle something, after you're done processing the message, you recycle it. And oh no, that's the internal. Give me a second. Process in. Ugh. Game mode, normal mode. Process in. After you're done processing a message, you recycle the message. So you call message pool recycle message with the message. You recycle the header, the data, and then the whole message. The data, basically each data implements its own recycle method, and it knows exactly where you need to recycle to. So for instance, the collision event message will recycle to the, if you go in here, it will recycle to the collision event message pool. So, oh my gosh, I feel like I'm talking so much, but that also covers recycling and pooling for the messages. Yeah, I think that's all I have regarding messages.